Dear students, good morning, good afternoon, and good evening. Based on the time zone at presently you are staying. First of all, I welcome all of you for our YouTube channel. You know very well, I am Selvamani Krishnamurthy, who is sitting in front of you. This is Machine Learning video lesson number 3. In previous lesson, we studied single linear regression using Excel. But in that, we struggled a lot. Our aim is we have one data set, hours and marks. That is known input, known output. To find out the marks for unknown input, we struggled. How? We need to find out sigma x, sigma y, sigma x square, and then sigma xy. After that, we found slope m using one formula. Then we need to find b, that is intercept, using another formula. Then only is possible. How to simplify this work? With the help of single linear regression supervised machine learning algorithm. That is what we are going to study in this lesson. As usual, I like to share my screen. I go, my screen is visible to all. Before that, in my laptop, I have one CSV file, study_marks.csv file. Okay, it contains some data, that is known input, known output. Let me open first. See it here, 2 column, hours and marks. 1, 2, 3, 4, 5. 60, 70, 75, 85, 90. This is known data, that is input and output. That means if any one student studies for 1 hour, you will get 60 marks. Same student study for 2 hours means 70 marks, like this there. If the same student study for 6 hours per day, how much mark you will score? That we don't know, because we don't know. That is what we need to predict. That means with the help of known data, hours is input, marks is output, we need to train the model. After model is trained, the model should predict how much mark that students will get if he studied for 6 hours. This is what our aim. Okay, good. Good. So lesson number 3, topic is supervised learning, single linear regression. So single linear regression model involves the following step. First one is identify independent input and dependent output variable. In our case, hours is a input, mark is a output. Is it clear? That means hours is independent. Based on the hours output, that is marks, will differ. So hours is independent input, mark is dependent output. Collecting data from CSV. Okay, that also we studied how to collect data from, how to import data from CSV file. Train the model with the known input. So we need to train the model with the known input and output. At last, predict the output for new input. These are the steps involved. Okay. See, before proceed programming, let us study something. sklearn. These are the concepts we are going to use in our program. First one is sklearn. sklearn is a short form of scikit-learn. It is an open source machine learning library in Python. With the help of sklearn only, we are going to achieve our machine learning algorithm. So sklearn has many tools for data pre-processing, model selection, training, evaluations, and deployment. Okay, so sklearn only we are going to use in our machine learning course. Linear regression is a one class. L should be capital, R should be capital. Linear regression is a class of sklearn model, which is used to perform linear regression supervised learning algorithm model. Okay, so with the help of linear regression class only, we are going to apply single linear regression supervised learning algorithm model. Fit is one of the method of linear regression class. This fit method is used to train the model by finding the best first line, best fit line for given data set. Okay, this fit method only used to train the model with the help of given data set. Predict method of linear regression is used to make the prediction after the model has been trained by fit. Okay, first what we have to do, we need to select the model. Then we need to train the model with the help of fit. Okay, after that, we need to make the model to predict with the help of predict function. I hope it is clear. Now see, already we studied formula for single linear regression. Y equal to mx plus b, already we studied. These two formulas we studied. M stands for slope, b stands for intercept, y is the output, that is number of the marks, x is the number of the hours. Okay, intercept underscore is an attribute of trained linear regression model. Already with the help of fit, we trained the model. Then intercept underscore is an attribute of trained linear regression model that represent intercept of the best fit line. To find B, no need to worry about this calculation. Simply using intercept underscore, we can find the intercept. B value we can find out. That is the using. COEF, quotient underscore, is an attribute of trained linear regression model that represents slope of best fit line. In previous case, if you want to find slope, you need to apply this formula. Now it is not needed. Just coefficient underscore is an attribute. This attribute you can use to find slope. Now we will see one small coding for single linear regression supervised machine learning model. As usual, we know very well import pandas as PD I am using. From sklan is a one module. Import linear underscore model. This linear underscore model is a submodule available under sklan. Fine. Data frame, I'm creating one data frame from my CSV file, what already I showed. Study underscore marks. Okay, this is the data frame I created. So hours are there, marks are there. Okay, this is the known data input and output. With the help of this known data set only, we are going to train the model. Now I need to create one single linear regression model. How to create? Very simple. LR equal to, LR is a one object. LR equal to linear underscore model. This is the submodule. Submodule dot linear regression. This is the class. That means we are creating one object. That object is said to be single linear regression algorithm model object. Now we are creating one model. Very simple. Simply putting LR equal to linear underscore model dot linear regression. It will create one linear regression module. Okay, algorithm model. Now we need to train the module with the help of fit function. So lr.fit. For fit function, we need to give two arguments. One argument is input, another argument is output. That is training the model with input and output. See, in this case, hours is the input. df of hours. Since we are using single linear regression model, single input is there. In some cases, many inputs will be there. At the time, we can use many input. So now in this case, df of hours, this column is input. If we are having many input, hours, comma, we can give. What is the output? This is the output. So hours is a input, marks is a output. With the help of these two columns of the data set, this single linear regression model is fully trained. That means 1 means 60, 2 means 70, it is trained. Now what is our aim? We need to predict for new input. Predict the output for new input. How? Very simple. LR.predict 6. The 6 is the number of the hours. New input, new single input. So it correctly predict the new value will be stored here. So 98.5 it goes a result. That means what? If any one student studied 6 hours per day every day, you will get 98.5 marks. Is it clear? Very simple. Not only for single input, many input or multiple input, it will predict multiple output once it's trained. How? LR that predict list of values we can give. 4 we have, 5 we have, but 4.5. That means if any one student studied for 4.5, 4.5 hours every day, how much mark you will get? 6 hours means how many marks you will get? 7 hours means how many marks you will get? See, you will get, just a minute, some problems there. Okay, so if anyone student studied for 4.5 hours per day means he can score 87.25. 6 hours means 98.5. 7 hours means 106 more you can get. I hope it is clear. Now what about slope and intercept? That also very simple. LR dot intercept underscore. So we will get intercept 53.5. This 53.5 in previous class we struggled a lot. M means slope. Slope equal LR coefficient. So 7.5 is M. 53.5 is intercept. I hope it is clear. Now let me demonstrate the same thing in front of you so that you can easily understand. Okay. Now we learn how to upload our CSV file. Just upload. So our file is available under study underscore marks. Uploaded. Okay. Now upload. Now study underscore .csv file is uploaded here. Now let us proceed for new Python 3. Now import pandas as PD. Already we studied. From sklan import linear underscore model. Now we need to import data from our CSV file. Okay, we need to create one data frame. pd.read underscore CSV. Our file is study underscore marks.csv. Now let me check. Now our data frame is ready. Hours as well as marks. Hour is the input, mark is the output. Next to our case, I need to create one model. LR equal to linear underscore model dot linear regression. Okay. So I need to create one new model. So new model is created. I need to train the model with the help of input and output. I have, okay, here ours is our input. Then df dot marks is our output. Okay. Let me check. If there is no error means this model, LR model, that is linear regression model, is properly trained. Now it is ready to predict the output for the unknown input. Now let me check. Predict marks equal to LR dot predict. Now I need to give new mark. Okay. For example, I am giving 6. 6 I am giving as in the form of list. Now what it will check, what mark it predict. So it predict 98.5. That means here we train the model with the help of this data. Okay, 6 is not available. Now in this case, the model predict the output for input 6. That means if any student studied for 6 hours per day, mean he will show 98.5. Not only for single input, for many input also it can predict. Let me check. Here 6 is there. Before that I can give 4.5 plus 7 hours. Okay, let me check. Here, if any student studied for 4.5 hours per day, mean he can score 87.25. 87.12 lies in between these two. If same student studied for 6 hours per day, means 98.5. Studied 7 hours means 106 more. Okay, I hope it is clear. What about slope and intercept? That also we can find out. Here, slope means B equal to, okay, LR dot intercept of B. Let me check. See, intercept we found. In same way, M for slope, M equal to our LR is trained model. Here, coefficient. Simply we can find out. Okay, no need to worry about anything. What we did it here, we imported one data set. This data set contains input, output, that is known input, known output. We created one single linear regression model. We trained the model with the help of input and output. Okay, here the model predict the output for new data input 6. Here the trained model predict the output for multiple input. I hope it is clear to all. Today, let me stop here itself. In next lesson, let's study something extra. Until then, thank you, student. Have a nice good day. Bye bye. See you.